So, we're going to talk about solar, wind, geothermal, and hydrogen. So, by the end of this, be able to list the different forms of solar energy and their application and describe how wind energy is harnessed and its contemporary use. Discuss the methods of harnessing the internal energy from the earth. It just sounds so mysterious, but it's not. And be able to explain the advantages and disadvantages of energy from hydrogen. Dun dun dun. Energy from the sun, it can be captured directly. In addition to driving the natural cycles of water and air movement that we tap in as energy sources, the sun also provides energy pretty much directly. Every day, Earth is bathed in solar radiation, an almost limitless source of energy. This amount of solar energy available in a particular place varies within an amount of cloudiness, time, day, season. So the average amount of solar energy available varies geographically, as you can see in this figure. The average daily solar radiation in the continental U.S. ranges from 3 kilowatt hours of energy per square meter to the Pacific Northwest, which is about 7 kilowatt hours per square meter, and even in some parts of the Southwest. All right, passive solar energy. We've already seen applications of passive solar heating, including like the positioning of the windows and the south-facing walls and the emit of solar radiation. Solar ovens have both environmental and social benefits too. The use of a solar oven in place of a firewood reduces deforestation, and in some areas, um, a wood burning fire can be unsafe. So having a solar oven means not having to leave the safety of your home to like go seek firewood. In addition to that, solar ovens are practical in their application. These are examples of passive solar heating and passive solar energy. So now we're going to address the active solar energy technologies. So in contrast to the passive solar design, active solar energy technologies capture the energy of sunlight with the use of technology that is included on a small scale, like solar water heating systems, photovoltaic cells, and a large scale concentration of solar thermal systems for electricity. And these technologies may include like solar water heating systems that have a lot of good applications. So solar water heating applications range from providing domestic hot water for heating swimming pools to a variety of heating purposes for businesses and your home. In the U.S., heating swimming pools is the most common application for solar water heating, and it is one that pays for itself relatively quickly. A household solar water heating system, like a domestic hot water heater, allows heat energy from the sun to be transferred directly into another liquid, which then circulates the hot water through the system. So the simplest solar water heating system pump is cold water, and that's directly controlled by a heating element. But this active system also has its drawbacks. Some benefits still include like it generating hot water for electricity without producing pollution, and it produces electricity on hot sunny days when the demand for electricity is really high. It also produces electricity during that peak demand hour that we've talked about, and so that'll reduce the use of fossil fuels and fossil power plants. A photovoltaic system, though, may be less expensive than this, and so photovoltaic systems offer as a system that you can capture energy from the sunlight, and it's converted directly to electricity. It's pretty cool. So the drawbacks to this would be that the solar panels are very expensive. Not to mention they're a real pain in the butt to manufacture and install. But the manufacturing process requires a very, very toxic chemical, a chemical slurry, I will call it. The textbook and the material makes it sound like there's a metal in there that's causing it to be, but it's not. It's a slurry of a bunch of junk and mixture of things that are extremely toxic. You can't just throw away a solar panel. Anyway, there's also an environmental cost associated with like the batteries for this system because battery storage, battery recycling, that's all an issue. So, I mean, it does have its drawback. So, the wind is another important source of a non depletable renewable energy. Wind energy is captured and generated from the kinetic energy from moving air. And wind is a result of this unequal heating of Earth that we've talked about before. And so warm air rises and cooler, denser air sinks, and it creates this like circulation pattern. So ultimately, the sun is the source of all winds, right? And it is the solar radiation and ground surface heating that causes this air to circulate. So before the electrical grid reaches rural areas of the United States, in the 1920s, windmills dotted the landscape. Today, wind energy is the fastest growing major source of electricity in the world. Today, the installation of this wind energy capacity has risen from less than 10%, less than 10, I'm sorry, 10 gigawatts in 1996 to more than 300 gigawatts today. So the increase of wind energy systems is definitely on the rise. So here you can see the generating capacity and the percentage of electricity that's generated by wind for a number of countries. So China has the largest wind energy generation capacity in the whole world, followed by the US, and then Germany, Spain, and then India. Despite its large generating capacity, though, the US obtains less than 6% of its electricity from wind. The largest amounts are generated in California and in Texas. And although more than half of the U.S. states produce at least some sort of wind generated electricity, Denmark, a country of only 5.5 million people, generates 26% of its electricity from wind and hopes to increase that figure to 15% by 2020. So, although the U.S. Currently obtains a small percentage of its electricity from wind, it is the fastest growing source of electricity in our country. I guess we won't have to wait very long to see if they do this by 2020, but this graph was generated in the year 2013. A wind turbine converts the kinetic energy of moving air into electricity in much the same way that the hydroelectric turbine harnesses the kinetic energy of moving water. Wind turns the blade of a wind turbine, and the blades transfer energy to a gearbox. That in turn transfers energy to a generator that generates electricity. A modern wind turbine, like the one that you saw when you started the whole unit, may sit on a tower as tall as 100 meters, 330 feet, and have blades that are 40 to 75 meters. That's 130 to 250 feet long. On average wind conditions, a wind turbine can, on land, might be able to produce 25% electricity, electricity 25% of the time, while its spinning might generate between 2,000 and 3,000 kilowatt hours, and in a year it might produce more than 4.4 million kilowatt hours of electricity. That's enough to supply about 400 homes. But these offshore wind conditions are what are most desirable for these wind turbines to generate electricity. And wind turbines on land are typically installed in these rural locations, far away from buildings and a population, a lot of people, and they must be close to electrical transmission lines with enough capacity to transport the electricity that it's generating. So, for these reasons, as well as some political regulatory reasons, facilitating the service and equipment, and usually this wind turbine practice. Wind turbines and wind farms are hard to come by. The number of wind farms is increasing in the United States and around the world, but wind farms are often placed on land that the wind blows about 25% of the time. And these offshore coastal locations, they're more desirable because the wind blows 35% of the time. So an offshore wind park, where there's a cluster of wind turbines usually, is often located right offshore in the ocean within a few miles of the coastline. And so regardless of where it's located, you can see that the basic structure of a wind turbine is all the same. There is a motorized drive that turns the turbine and makes sure that it stays facing the wind, and that takes energy. And then there's the generators actually located in the back of the actual turbine, and then there's the blades and the gearbox. And so the fascinating thing about these turbines is that they will direct themselves, and they will face the wind blowing direction. So they're movable, where like a hydroelectric power plant is not. But the coolest part about wind turbines is that they're non-depletable. Wind energy offers many advantages, just like sunlight. It's basically free and it's clean, and the amount of availability tomorrow does not really depend on how much we use of it today. So once a wind turbine has been manufactured and it's installed, the only significant energy input comes from the wind. And the only sustainable fossil fuel input that is required is a pretty small amount. And so once the turbines are installed and the fuel workers need to travel to these wind farms, just intermittently to do maintenance and check on the equipment. So they basically run themselves, and they don't produce any pollution or greenhouse gases, unlike everybody else, the hydroelectric, the CST, and other conventional thermal plants. Wind farms can share the land for other uses. For example, what I mean by that is wind turbines on land may also share an area that you can have cattle grazing on. So there's a lot of benefits to this, but there's also some disadvantages. Most of these off-grid residential wind energy systems rely on a battery. And so the battery only stores so much and can only be so far away from the turbine. The turbines can have a lot of noise associated with them. Not to mention they are gigantic and people consider it to be unattractive. Although I find them extremely impressive. Like I've been traveling on Interstate 75 up towards through Ohio and up to Michigan, and there's huge wind energy fields and people climbing them. Like you can barely see the person climbing them. They're like ginormous. This a spectacle to look at. And then also something like as many 40,000 birds are killed by wind turbine blades in the United States each year. And I'm not laughing because that's so sad. I find it funny that there's people actually calculating this and publishing this. And if you're a bird, why would you fly directly into a moving object like that? So there's got to be some sort of engineering or ingenuity, creativity that we can do to kind of save 40,000 birds a year, like we've done to save dolphins getting caught in tuna fish nets. In addition to birds, we're also talking about bats. Now, bats can be a problem, right? Because they eat insects, and so they're pest control. But bats are also killed by these wind turbines. And, that's where you come in. So let's find a way.